Our next type of angles are inscribed angles. We had central the other day, and now we have inscribed. Okay, inscribed angle whose vertex lies on the circle and whose sides are chords of the circle. So we're focusing in on this corner, and it lies on the edge, on the rim of the circle. ABC is an inscribed angle. Okay. Are these inscribed? Is the corner, the vertex of the angle on the rim? No. All right, what about this one? Yes, good. All right, what about this one? Nope. What is that? That's central. All right, and that? Yes. So, the inscribed angle is going to be a little bit trickier than the central angle we did last time. When I'm looking at, where's my dot? Okay. When I'm looking at the, I can't get these little highlighters to working. It's too dark. All right, so when I'm looking at the angle, now notice that you can use your pencils again if you need to highlight the angle. There's still the intercepted arc. It's like, what's the arc that's inside of here? See how it's like holding the red part right there? That's the arc it's going to open up to, and that's what it goes with. But instead of being equal, the arc is twice as big as the angle, or the central angle is half the size of the arc. You just got to remember, am I multiplying by 2 or am I dividing by 2? But think, here's the arc is big. What happens when you go up into this corner? It's getting smaller. So the angle should be smaller than the arc. When you get finished with your numbers, just think, is that smaller like it should be? So that's the inscribed angle, and that's the arc. Now there's a special case that can happen. Notice angle B is not truly an inscribed, because this is coming out here, this tangent is doing something weird and hanging outside the circle, and it's supposed to be made with 2 arcs, but 2 chords, sorry. The corner of the angle is still on the rim of the circle. So just like on the inscribed ones, even though this technically is not called an inscribed, it's going to be worked like the inscribed. So the arc is this little AB section right in here, and so that would be, let's say, if I just gave you a number, this would be 160, then the angle would still be half, and it would be 80 degrees. Even though it's not called inscribed on that type, it still worked like it, so I put it in this category. Alright, so then they get a little crazy. And we're going to talk about this in class too, I think, if I remember. Alright, so where's the intercepted arc? If I'm looking at angle X, what's the arc it goes with? Well, those little lines will help you to be able to highlight it. Just take a couple pencils and stick it on there. What's the name of the arc? YZ. Arc YZ is what X is opening up to. Alright, next, what does W open up to? YZ. And so they both had YZ as an arc. So what does that mean? They're both on the edge. They both have the same arc. They're going to be the same size. X and W are going to have to match because they have the same size arc and they're both inscribed angles. Now, if one was central and one was inscribed, then no, they wouldn't match. But if they're the same type and they got the same arc, then they're going to match. All right, see if you can figure out the shortcut here. What XYW opens up to? Angle XYW opens up to XW, arc XW. What does angle WYZ open up to? WYZ, that arc, it opens up to which arc? WZ. Have you figured out the shortcut? What's the shortcut? Y, X, the first letter and the last letter in the name of the angle would be the arc. And they give you all 3 points. Look at it. Y, Z, X. Y to Z to X. YW. Wait, I'm doing the wrong one. I did YZW. Sorry. All right? So Y, Z, X. So YX is your arc. It opens up to right there. So it's the first letter and the last letter. XZW will be XW. WZY will be WY. So, cool little things. Alright, so let's practice a few for your notes. If we're looking for angle Y, is it going to get bigger or smaller from the 110? Coming up in here gets smaller, so it's half the size. So it would be half of 110, 55. Okay, we don't see a number, but do we? What's that? 90. So what's going to happen when it comes out here? It's getting a lot bigger, isn't it? So that's 180 for arc AB. 180. All right. Then we've got this tricky one here. We're going to look at angle. This 20 degree is going to open up and be 40, doubling when it comes out, bigger and bigger. All right, but I'm asking for GF. How much is this going to be? I want you to start watching for things like this right here. What is that? That's the center of the circle. You got a diameter going right through there. When you see that dot, be watching. You don't see the dot a lot. It's not all the problems have it. But when you do see it, it's telling you, hey, 180. Forget about all this back here. We don't need that. We need this half to make 180. We already got 40. When you subtract it, you get 140 for GF. It'll be 140 for that arc. All right, next we got X, we got 60, we got Z, we got 60. X opens up to the 60, Z opens up to the 60. So they're going to match. Remember how we talked about that a minute ago? So they're going to match. They're going to be equal. But what are they? Half the size of 60. 30. Each of them 30. And then expect to see this one on your test. New numbers, of course. It's a triangle inside of a circle, but don't let it freak you out. Start with the basics that you already know how to do, and I would focus on the angles. Like I know you got 100 there. Look at the 60. 60 is the angle. Focus on that. It opens up to the bottom, right? So if that's 60 there, it's getting bigger and bigger, 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 bigger. It's going to be, of course, 120 down here at the bottom. All right. And then instead of trying to say, well, what 100s should be something, what's it go with? Focus on the angles. Angle B is going to be opening up like this. So the arc for angle B is all this up inside of it, and we don't have anything there. So we'll come back to it, that's okay. But what about angle C? Focus on the angle. Angle C is right here. C is going with that 100. Look at it. So C would end up being 50. Now there's a couple things you could do to figure out B and to figure out arc AC. We already got BC is 120. AC we don't know. Angle B we don't know. Angle C is 50. What could we do to find angle B? Well, you see that triangle right there? I hope by now that you know that triangles add up to 180. Subtract 60 and 50 on the triangle and you get 70 for that angle. Okay? Then you could use that 70 to figure out AC, because that's going to be the angle, the arc it opens up to. Angle B, and that's 70 open up that way. Or you could go on just the outside. What is the whole outside supposed to be? 360, and you're missing this one piece. 360 minus 100 minus the 120 at the bottom is going to give you 140. And so that's 140, and AC is 140, and B is 70. And that's what it should have been. It doubled to make that 140 that way. So your choice on how you work that one. Okay, a little bit trickier now. Just focus on the angle that you know and the angles you're trying to find. 50 opens up to AC, so this should be 100, no doubt. But then what does the Y open up to? Get the All right, little marker. Angle Y comes out like that. Oh, it goes to the 100 too, doesn't it? So angle Y would be 50. And then you can say, what does X open up to? Angle X, same thing. They both, all three of them, went up to the 100, so all three of them are going to be 50. And they're on the edge, inscribed angles. There you go, another one. So X is pretty simple. X opens up to the 40, so X is 20. Well, what about Y? When I start looking at the 50, 50 is not just Y, 50 is coming all the way out here. So it's all of this goes with the 50. How much would all of that be out there in the blue? 50 doubles to make 100. Remember, that's the small one at the angle. So now I got 100. And to find Y, 40 and Y add up to 100. Remember segment addition and angle addition? Well, now you've got arc addition postulate. So angle Y would be 60, arc Y would be 60 degrees. They add up to be 100.